Isaac Newton said that I do not define time, space, place, and motion as being well known to all. Only I must observe that the common people conceive those quantities under no other notion but from the relation they bear to sensible objects, and hence arise certain prejudices from the removing of which it will be convenient to distinguish between into absolute and relative, true and apparent, mathematical and common. After that, let's talk about the history behind this chapter. Mathematics is now applied to all branches of science, engineering, commerce, and the social sciences. But traditionally, mathematics was applied to the study of science and principally to physics. The study of physics depends on mathematical methods and models, particularly calculus and differential equations. From the 17th century onwards, mathematics developed in two directions, pure and applied. One of the first area of applied mathematics to be studied in the 17th century was motion in a straight line, often referred to as the kinematics of a particle moving in a straight line. Sir Isaac Newton first developed both the differential and integral calculus in the 1660s, then shortly afterward turned his attention to kinematics. In his 1671 work Treatise on Methods, Newton listed the two central problems of calculus as: first, given the length of space continuously, that is, at every time, to find the length of the motion at any time proposed. In other words, find the speed of a particle given the position. Second, given the speed of motion continuously, to find the length of the space described at any time proposed. In other words, find the position given the speed. These problems were the motivation for Newton's work on calculus. In this module, we deal with the quantities position, displacement, distance, velocity, speed, acceleration, and time. We stabilize mathematical models for the motion of a particle in a straight line. Initially, we deal with the special case of constant acceleration. The study of motion in a straight line should be included in any introductory course in calculus. It serves both as an context for understanding the basic concepts of calculus and as an important application of calculus. After that, let's go on and discuss point object. Point object: if the length covered by the objects are very large in comparison to the size of the objects are considered to point objects. After that, let's discuss reference systems. The motion of a particle is always described with respect to a reference system. A reference system is made by taking an arbitrary point as origin and imaging a coordinate system chosen from a given problem constitutes the reference system for it. We generally choose a coordinate system attached to the earth as the reference system for most of the problems. After that, frame of reference: a coordinate system or set of axes within which to measure position, orientation, and other properties of objects. In all cases, a reference system still remains unattached to the real world. It is the office of the realization, the establishment of real position on the surface of the earth for it to become a reference frame. The reference system and the reference frame depends on one another. Neither is useful without the other. Just as position on the earth are useless without an origin, orientation of the axis, definition unit, and so on. Without a reference frame, the coordinates of the control points are like chess pieces without a chessboard. They can be arranged, analyzed, and moved about, but they have no meaning. After that, let's discuss total path length or distance. For a particle in motion, the total path length of the actual path traversed between initial and final position of the particle is known as the total path length or distance covered by it. Distance is a scalar quantity. SI unit of distance is meter. Dimension of distance is square bracket capital L. Example, if a boy is going to school by cycle from his house and travels a path length AB is equals to 5 meter, BC is equals to 10 meter, then total path length or distance traveled by him is equals to AB plus BC is equals to 5 meter plus 10 meter is equals to 15 meter.